Hey guys, hope you're doing good. Today we are going to look at a problem called as Divisor's Game, and it's on Leetcode. It involves recursion, backtracking, and dynamic programming. It's considered an easy problem on Leetcode, but still it captures all the essence of dynamic programming. So let's get started. Name of the problem is called as Divisor's Game. So there are two players, Alice and Bob. So they take turn playing the game and Alice starts first. So initially there is a number n on the chalkboard and on each player's turn that player makes a move. So what is that move? So basically he or she chooses a number between 0 and n such that x divides n, which means that that number is a factor. In other terms, n mod x is equal to 0, and then he replaces the number on the chalkboard with n minus x. He takes a factor and subtracts that from n. And also, when the player cannot make any more moves, then they lose the game. So basically, both of them take turns, and when one of them reaches 1, so then there is no factor to choose from. So they, whoever gets a 1, so they lose the game. So we need to write a program to take this number and return true or false to indicate whether Alice can win the game or not. And also both the players play optimally, in the sense both the players play to win, right? So for example, there is this number on the chalkboard, 100, and on the left is Alice and on the right is Bob, and Alice goes first. So she has to take a number from 0 to 100, between 0 to 100, which means that it is a factor. For example, 50 is a factor, 25. So if she takes 50, then she has to subtract 50 from 100 and replace that number on the board. And then now it's Bob's turn. She can also choose 25, and if she chooses 25, then she replaces the number 100 by 75, that is 100 minus 25, and then Bob gets 75, and now it's Bob's turn. And if Bob gets 50, so he can choose 25 or 10 or 5. So whatever is the factor of 50, he can choose that and subtract that factor from 50, and then it will be Alice's turn. So if he chooses 25, then 50 minus 25 is 25, and that will be the new input, and then it will be Alice's turn, and 25, and it will be Alice's turn. So finally, whoever gets a 1, so the game continues like this, and whoever gets a 1, he or she loses. For example, if Bob gets a 1, he cannot proceed any further because he cannot choose any factor which is less than 1. So what is the strategy that each of the player will use? So select a factor x such that opponent ends up with 1. So how do we know which factor to choose? So in code, what we can do is, we don't know further ahead like which factor which will lead the other person to end up with a 1. So we try out all the combinations, try out all the factors, and pick the one which makes the other person lose. So basically the strategy is, if I choose a factor and you lose, I win. So if I win if my opponent loses. And we have to remember that Bob also uses the same strategy, and Alice also used the same strategy, because in the description it's given that both the players play optimally. So whatever strategy Alice uses, Bob also uses the same thing. So let's take an example and see what I mean by that. So initially the game starts with n is equal to 6. So now it is Alice's turn. Alice can choose 1 because 1 is a factor of 6. She can also choose 2, or she can choose 3. So in each cases, so if she chooses 1, she will she will end up with 5, and if she chooses 2, then 4 will be on the board, and if she chooses 3, 3 will be on the board, and Bob will get these numbers. So based on what Alice chooses. Now it is Bob's turn. So when it comes to Bob, for 5, there is only one factor, so which is 1, so he has to choose 1, so he doesn't have option. But if we got 4, then he has two options. Either he can choose 1 or he can choose 2. And in case of 3 as well, there is only one option, which is 1. He has to choose that and subtract that and get a new number. So which will be input to Alice. So now it's Alice's turn. So she does the same thing, like chooses the factors. But here, what I'm trying to show is how the overall game proceeds. Here, whenever Bob gets a 1, then Bob loses. He cannot proceed further. So that means Alice wins. Bob loses, Alice wins. So these are the cases where Bob gets a 1 and he cannot proceed further, and Alice wins. But there are also cases where Alice loses, which means Alice ends up with a 1 and she will lose. So Alice has to avoid this path. So now Alice knows like which all paths will lead to win and which all paths lead her to lose. So what she has to do is pick the factor which ensures her win. So for example here, so 6, she picks 1, Bob will be end up with 5, and then Bob will have to choose 1, and Alice will end up with 4. Now she chooses 1 and Bob will end up with 3, and so he has to choose 1, and now it's Alice's turn and she will choose 1 and Bob will lose and Alice wins. Also in this case where Alice first chooses 3 instead of 1, and now Bob is left with 3 and he has to choose 1, and so Alice gets 2, she chooses 1 and 1 is remaining, Bob gets a 1 and Bob cannot proceed further, so he loses, so Alice wins. So in both of these paths, Alice wins. We are only interested in knowing whether or not there is a way through which Alice can force Bob to lose or Alice can win. So we are not interested in the actual path or like what turns does Alice takes, but we are only interested in knowing whether or not Alice wins. So how do we write code for this? See here, all we are doing is for both of the players, we are using the same strategy, and the strategy is to try out all the different options and see if the other player loses. And also you have to note that it doesn't matter who is playing in the code, so it keeps alternating. If it is Alice's turn, so she passes on the same method to the Bob and see if he loses. So it doesn't matter within the code, it doesn't matter whether it is Alice or Bob, it's the same strategy. But because Alice goes first, so we are interested in the output of the first method call. When you say try all options and see which one will lead Alice to win or which one will lead a player to win, then the first thing that should click in your mind is backtracking. Backtracking is the best tool for these kind of problems where you're trying out all the different candidates one at a time and seeing their output and backtracking if it doesn't work out. So let's see how we can use backtracking to solve this problem. So first we have to define a recurrence relationship. See, in backtracking we use recursion. So if we define a recurrence relationship, it becomes like pretty straightforward to implement that in the code. So what is the recurrence relationship? So first we have to see what are the input parameters. There is only one parameter, which is n, which is the remaining number on the chalkboard. So it's pretty straightforward. And then what is the return value of the function? So it is true or false. Can the player win or not? So the base case is if n is less than or equal to 1, return false, which means that if a player gets a 1, he loses, so we return false. So let's define the recurrence relationship. As I mentioned, the idea is to try out all the different options and find a factor which causes the other player to lose. So let's call the method can_win, and it takes that parameter n, and if can_win is equal to not can_win n minus x, which means that if I can win if other player loses, and we have to try out all the different factors, and we are only interested in knowing whether or not such a factor exists. So as soon as we get one of that factor which causes the other player to lose, then we stop and we return true for x such that x is greater than 0 and less than n, and n mod x is equal to 0. So this is a Java code. This is a pretty straightforward implementation of the recurrence relationship that we saw in the last slide, and this is the Python code. So this is a backtracking solution, right? It uses recursion. The time complexity is O of 2 to the power of n. This is pretty slow because this is polynomial. So why is it so slow? If you look at the tree, you can see that we are solving the same problem over and over again. For example, Alice gets a 4. Regardless of whether it is Alice or Bob, they follow the same strategy, and we know the result for 4. But we end up solving, whenever we receive 4, we do the same steps and we end up like solving the same problem over and over again. So one of the characteristic property of problems which can be solved using dynamic programming is overlapping subproblem. So now we have a recursive solution. So how do we solve the problem of overlapping subproblems? So how do we eliminate all these overlapping subproblems and speed up the whole process? For that, we have to use dynamic programming, and one of the technique in dynamic programming is memoization, which means that instead of solving the same problems over and over again, we cache the results of the subproblems and reuse them instead of solving them multiple times. So cache the results and reuse them when needed. How do we cache the results? Like, what do we use to cache the results and what do we cache? So input parameter is an integer n, and return type of the method is boolean. So we have to use a boolean array as the cache. The value of the n will become the index, so that will be the key to the cache, and value stored in the cache is a boolean value, which is true or false. And null is our default value, which means that if for a given index n the value is null, which means that this problem has not been solved yet, so we have to solve it. We have to modify our recursive solution to introduce a cache. It is pretty straightforward. Code is exactly same as the recursive solution, but we have introduced a cache here. We pass in the cache as the input parameter, and then we check in the cache if for the given input parameter the problem has already been solved or not. If the subproblem has already been solved, then it means that there is a non-null value in the cache. We just return that value from that cache. If it is not already solved, then we have to use the same recursive solution to like calculate the result, compute the result, store the result back into the cache. So here a result is true. Before returning true, we just save that value inside the cache as true. This is the Python version of the code. One thing to note here is when we are selecting the factor, so we were going from 1 to all the way to n minus 1, which is we have to select a factor which is like greater than 0 and less than n. So we used to go all the way from 1 to n minus 1. But if you think about it, the biggest factor or the x can be at most n by 2. So there cannot be any factor which is greater than n by 2. For example, like if n is equal to 100, then the biggest factor can be at most 50. It's a slight enhancement. and this is the Python version. And so this is especially helpful in the worst case, which is in case Alice cannot win, she has tried all the factors, then we don't have to look for the factor beyond n by 2 because it doesn't exist, so we can just return false from there. So what is the time complexity of this solution? So here we are solving every subproblem only once. So the way we calculate the number of subproblems is by evaluating the for loop. See here, number of subproblems is n, and to calculate each of the subproblems, so what we are doing is we are using a for loop which goes from 1 to n by 2, and if you apply that, so what you will get is n into n divided by 2, which is equal to n square divided by 2. So the time complexity of this solution is O of n squared, which is much better than O of 2 to the power of n, right? And what is the space complexity of this memoization solution? We are using a cache of size n, so the space complexity is O of n. Okay, so that's our dynamic programming solution. We improved the performance of the solution from all the way to O of 2 to the power of n to O of n squared. So there is an alternative solution for this particular problem. So what is the alternative method? Here it is, and it is just one line of code, which is if n is divisible by 2 or n is an even number, we return true. If it is not, then we return false. I know this is a bummer, we didn't have to do all these things. Let's see why this works, right? So there is like a mathematical proof involved in this, so let's go over that. So we have to consider both the cases where n is even and when n is odd. Let's see why Alice always wins if n is even. See, when n is even, so what is the base case? So the base case is 2. Alice gets 2 and Alice takes 1 from it because that's the only factor, and leave 1 to Bob. And Bob will get 1 and he cannot proceed further, so he will lose. So Alice always wins. Now let's see other cases where n is even. So for any even number, Alice can take out 1 or any odd factor from it and make it odd. So basically, if Alice gets even number, she can take 1 or any other odd factor and make that number odd and give it to Bob. So Bob will get an odd number. Now if Bob gets an odd number, factors of an odd number are always odd. So the x that Bob chooses are always odd. For example, factors, if Bob gets 9, the factors are only 1 and 3, both are odd, right? Like for factors of 15, 1, 3 and 5, all three are odd. And if you subtract this odd factor from the odd number, what you will get is an even number. So difference between any two odd numbers is even. You can try it out. So no matter which factor Bob chooses, Alice always ends up with an even number. So eventually Alice will end up with 2 because that's the base case, and she wins. So this is a mathematical proof. But in interviews, if this question is asked, unless you know this proof, you cannot come up with this thing in like an interview of like half an hour or 45 minutes. So don't waste your time like trying to come up with like a mathematical proof or like trying to see if there is any alternative method. You have to go through the coding techniques, for example, recursion, backtracking, dynamic programming. Even if you know why this thing works, even if you know like this solution, like one-liner solution, it's not a good idea to just go for it and like tell the interviewer that this is the thing, because then you have to give the proof, and if you are able to give the proof, then it means that you have already seen this problem, in which case, so the interviewer might give you another problem, or he can give you less marks because he was not able to assess anything, and you are being too smart, right? And now when n is odd, if Alice gets an odd number, then Bob will always end up with an even number because of the proof that we saw earlier, and Bob can force Alice to lose just by taking odd factors from n, right? So it's the opposite, where Bob does the same thing which Alice did to Bob. So time and space complexity of 1. So it's a constant time operation. That brings us to the end of this video. Hope you liked it. Take care. If you want to learn more about dynamic programming and also master it, I have put together a course on Udemy called as Master the Art of Dynamic Programming. I have included the link below in the description, and if you use that link, you can get 60% off on the original price. Hope you find it useful. Thanks. Bye.